Okay, guys, what I'm going to do today for you is I'm going to model one of these practice problems for our Lewis structures. So I'm going to show you on my screen, that way you have an example to follow and you can work on the rest of these on your own. Okay, so remember we took guided notes on these, so you have notes, but I did also include the procedures of our notes we took on how to do these step by step. Okay, so if you remember from the notes, there were kind of 6 steps. I basically took those steps with any important information and put them on this slide for you to reference. Okay, so the example I'm going to do for you today is H2S, which we have right here, H2S. Okay, so we're going to go through these steps together. So step 1 is that I'm going to count the total number of valence electrons we have. Okay, so that's exactly what I'm going to do. So counting the total number of valence electrons. So let's start with our H2. I'm just going to copy and paste my H2 over here. Okay, let's see, what am I doing? Okay, never mind, I'm just going to type in H2. Okay, so we're going to, let me make sure I insert my subscript. Okay, so calculating the total number of valence electrons. So if you find hydrogen on your periodic table, we know that hydrogen has 1 valence electron. Okay, and we're going to multiply that by the number of hydrogen atoms we have. So in this scenario, we have H2. So we have 2 hydrogen atoms. So 1 times 2 gives me 2. So pretty simple math. We're going to do the same thing for our sulfur. So find sulfur on your periodic table. Identify the total number of valence electrons. Sulfur has 6 valence electrons. We multiply it by the number of sulfur atoms we have, which is 1. So 6 times 1 gives us 6. Okay, so I'm going to record that number. I'm going to add those 2 together over here. Just let me change my font color. Okay, so 2 plus 6 gives us 8 total valence electrons that we have to work with. Okay, so now that we've calculated that, we move on to step 2. So step 1 is done. We've calculated the total number of valence electrons. So step 2 is we have to identify the central atom, and we're going to bond the atoms together using a single bond. Okay, so we have H2S. Okay, so my central atom, normally it's the least En value atom is in the middle, or the atom right first, or the atom that there's only one of. So in this scenario, sulfur is going to be our central atom. Okay, so I'm going to click on my S, my sulfur, and drag it up into my box where I'm going to draw my Lewis structure. Okay, and that means I know my hydrogens are going to be on the outside, so I'm going to drag them up here. Okay, do note that it doesn't necessarily matter if you put them on the side like this or if I wanted to stack them vertically. Okay, it's the same answer. It's tomato, tomato. It does not matter. Either way is correct. Okay, but I'm going to just stack it this way just to make it easier. Okay, so I've identified my central atom. I'm now going to add a single bond between the central atom and we call these terminal atoms. Terminal meaning the outside. Okay, so there we go. I've done step 2. I've added my single bonds. So now I do step 3. Step 3 is calculate the remaining number of valence electrons we have to work with. Okay, so we're going to calculate step 3. I'm going to go over back into this box here, just so we can kind of keep track of everything underneath. Okay, so remember we've used 2 bond lines. Each bond line represents 2 electrons. So remember we had 8 total to start with. We used 4 electrons already, right? If I count each line, this is 2, this is 4. So we've used 4 valence electrons, which means we have 4 left. We have 4 valence electrons left to use. Okay, so That takes me to step 4. We are going to use the remaining valence electrons to satisfy the octet rule or the duet rule, or any exceptions that fall under this category. Okay, so in this scenario, okay, normally we would add our electrons to the outside, okay? And actually, because I have 4 left, I'm just going to drag my 4 electrons that I'm going to use just up here so I can keep track. 1, 2, 3, 4. Okay, and then I'm going to now place them. So normally, like I said, we would place them on the outside atoms. Okay, but in this scenario, we have hydrogen. Hydrogen is already satisfied. Remember, hydrogen only requires 2 electrons. And if we look, okay, the lines that are bonded to hydrogen count as 2. So hydrogen is happy. So in this scenario, we are actually going to add our electrons to our central atom, sulfur. Okay, 1, 2, 3, 4. Just like that. Okay, so I have completed step 4. So what I'm going to do, I'm going to double check. Did I satisfy the octet or the duet rule for every single atom? Is every atom happy in our molecule here? So I'll start with the hydrogens. Hydrogen, there's 2 because it has a line. So hydrogen's good. The hydrogen on this side is the same thing. Hydrogen's happy. And then sulfur, I count up, is sulfur happy? I have 1, 2, 3, 4, 5, 6, 7, 8. So yes, sulfur is happy. So we have satisfied the octet rule. Okay, so in this scenario, we don't need to do step 5 because step 5 is if the octet rule is not satisfied, but it is. So we're good. We don't need to add multiple bonds. Everyone's happy. Nothing else we need to do. So the very last step, step 6, is just to check our work. So we already verified our octets. Okay, the last thing we want to do is just to make sure that we ended up having 8 total electrons in our drawing. Okay, so we're just going to count just to make sure we didn't accidentally lose or add any extra electrons. Okay, so each line is 2, so 2, 4, and then each dot is 1. So 4, 5, 6, 7, 8. And that is exactly how many total valence electrons we should have. So we're done. We're good. We've checked our work. We've gone through all the steps. Something else you are able to do, in the bottom, down here in the bottom right, I don't know if you can see it. See, my camera is kind of blocking. There's a little orange box and it says answer key. Okay, and it says delete to check your answer. You can either delete it or you can just move the answer box and you can check your work. Okay, so this isn't meant to trick you. It's meant to be a way for you to check your work and making sure you are doing it correctly. Okay, guys, so that is this one. This one is done for you. Feel free to watch this video again to go through the steps if you need, but you should be good to go. Go ahead and give the rest of the assignment a try.